Whenever a developer pushes code to a repository or an admin logs into a server halfway across the globe, there's this invisible guardian working behind the scenes. It's called Secure Shell, or SSH, and it's basically the protocol that builds a private, encrypted tunnel for your data right through the middle of the very public internet. So here's our game plan for this explainer. We're going to start with the basics, what SSH even is. Then we'll get into the fun stuff, what I'm calling the digital handshake, to see how a connection gets built. After that, we'll cover the all-important identity check, take a look inside the secure tunnel itself, and finish up with a peek at the security toolkit that powers the whole thing.
All right, first things first. What exactly are we talking about when we say secure shell? Let's just lay the foundation for what it does and, more importantly, the promises it makes about keeping your stuff safe. At its heart, SSH is just a set of rules, a protocol that lets two computers talk to each other securely, even when the network between them is completely wide open and untrusted. You can think of it like creating a private, armored car to move your information across a chaotic public highway.
Now, this is where it gets really interesting, because it all rests on these three pillars. Confidentiality, well, that just means no one can listen in. Integrity means the data you send is exactly the data that arrives, no sneaky changes. And authentication means you're positive you're talking to the right machine, and it's positive it's talking to you. It's a three-legged stool of security.
And this just shows how much you can do with it. SSH is definitely not a one-trick pony. The classic use case is logging into a server's command line from far away, but that same secure connection is what makes secure file transfers with tools like SCP and SFTP possible. You can even use it to wrap up other, less secure protocols in a nice, safe layer of SSH encryption.
Okay, let's get into the second part, how this connection actually gets built. You can't just start sending secret messages. First, the client and the server have to go through this really careful, structured dance to build trust and, most importantly, create a shared secret. And here it is. This is our roadmap for the whole process. It's just a beautifully logical sequence of events. We're going to walk through each of these 5 steps to see how a connection goes from being a simple request to a fully fortified private channel. It all kicks off with a simple hello. The client machine reaches out to the server on its default listening post, which is port 22. Right now, they're just setting up a basic line of communication and agreeing on some ground rules, like which version of the SSH protocol they're both going to speak.
This is where the real magic starts. Using a super clever algorithm like Diffie-Hellman, the client and server work together to cook up a brand new secret encryption key. And the most amazing part? They create this shared secret without ever actually sending the secret key over the network. It's like they each pick a secret color, mix it with a public color, and exchange the results. Then they add their original secret color to what they received, and boom, they both arrive at the exact same final secret color, all without revealing their original secrets.
And here's the crucial point. That session key they just made is totally temporary. It's a one-time use key. It's used for this single conversation, and then it's thrown away forever. This is a feature called forward secrecy, and it's incredibly powerful. It means that even if some attacker manages to steal the key for one of your sessions, they can't use it to go back and decrypt your past conversations, or any future ones. Every single session is its own isolated fortress. Okay, so now the client and server have a shared secret. Awesome. But they still don't really trust each other yet. Before any sensitive data starts flowing, they have to prove who they are. And the server has to go first. The server basically holds up its ID card. This ID is a special key called a host key. It sends the public part of this key over to the client and says, "Here, this is me." And now, the client has to decide if it actually trusts this ID. So how does the client decide? Well, it checks its contact list. This list is a little file on your machine called known hosts. The very first time you connect to a new server, SSH asks you, "Hey, I've never seen this server before. Do you trust it?" If you say yes, it saves the server's public key. From then on, every time you connect, it checks the ID the server presents against that saved record. If they don't match, you get that big, scary warning message that you might be talking to an imposter. So once the client is happy that the server is legit, the tables turn. The server says, "All right, I've shown you my ID. Now you prove who you are." It's finally the client's turn to authenticate. And you've really got 2 main ways to do this. You can use a password. It's simple, we all get it, but it's also way less secure. Or you can use the much better method, public key authentication. With this, your client doesn't actually send a secret. Instead, it just proves that it has the correct private key by solving a little cryptographic puzzle from the server. It's a bit more work to set up, but this is the industry standard for a very good reason. It's just way more secure. At this point, the whole handshake is done. Identities are verified, a shared secret key has been created, trust has been established on both sides. The secure tunnel is officially open for business.
Now, from this moment on, everything that travels through this tunnel, every command you type, every file you send, every response from the server, is completely scrambled using that temporary session key we made back in step 2. To anyone trying to snoop on the connection, it all just looks like random, unreadable junk.
But SSH adds one more layer of protection. Every single little packet of data gets its own digital signature, called a message authentication code, or MAC. This proves two things. One, that the data really came from who you think it came from, and two, that it hasn't been changed at all, not even by a single bit while it was traveling. This is the guarantee of data integrity we talked about earlier.
So we've gone through the whole process, but what are the actual tools, the specific algorithms that are making all of this work? Let's take a quick peek under the hood.
This gives you a great snapshot. You can see SSH isn't just one single algorithm, it's a whole suite of them, a whole toolkit. It uses one type, like AES, for the fast encryption of the actual data. It uses a totally different type, like Diffie-Hellman, for that clever key exchange. And it uses yet another set, like RSA or the newer ED 25519, for the authentication signatures. Each tool is highly specialized for its own job.
So if we just zoom out and look at the big picture again, you can see this really clear, logical flow. It starts with a basic, insecure TCP connection. Then, layer by layer, SSH builds up security. First, it creates a secret key. Then, it verifies everyone's identities. And only then, once everything is locked down, does it open the channel for the actual encrypted session.
And the main takeaway here is that this powerful tunnel isn't just for typing commands into a black screen. You can actually use it to forward traffic from other applications securely. That's called port forwarding. It's a secure backbone for those file transfer protocols we mentioned. You can even use it to run graphical desktop applications on a remote server. The secure channel is the foundation you can build all this on top of. You know, that quote really says it all, doesn't it? It takes the wild west of the public internet and carves out this private, trustworthy, secure corridor just for your data to travel through. It literally creates trust and privacy where, by default, there isn't any. And that really leaves us with a final thought to chew on. SSH has been quietly securing the fundamental plumbing of the internet for decades. It really makes you wonder, what would our digital lives be like if applying the same robust, layered model of trust and encryption was just as straightforward for every email we send, every message we post, and every bit of data we create online?